What's up, everybody? Today we're going to be looking at the torso file of the exoskeleton I'm designing for the Hacksmith. You know him, James Hobson. If you know about me, you know about him. This video is my presentation to James about this file, and we're going to take a look at it. It's my favorite file to design, and also the most difficult one. And it came together pretty quick, which is a good sign. I think we're going to get this suit design done in a reasonable amount of time, which is good. Let's just start with like the big picture here. Let's put the me inside of it. And remember, this file has been rescaled to fit James. So this, even though it's a scan of me, it's gonna fit James, who's taller than me. So that's me inside of it, and it's pretty sweet. Let's look at how it moves, because that's where we should start here. So I'm gonna turn that back off. And we're gonna come in here and we're gonna look at a motion study that I created. And these things are terrible. But I was able to get it working. So the first motion is here in the shoulder girdle, or the sternoclavicular joint. So it's where your clavicle meets your sternum, and so that goes up and down like this. So if you go up and down like this with your arms, your shoulders, James, you'll have that motion. I've removed one axis of rotation, which is forward, because it's really small and it adds a lot of complexity to the suit. It was the most complicated part of getting my suit made. So I took that out completely, just to make sure this actually works. And our return on investment, the ROI on having that joint in there was not that high anyway. So I removed it just to make sure this thing works. The next joint is let's flip around to the back side. Let you guys look at that for a second. That is internal and external rotation of your shoulder. So if you go like this, if you take your arms, I have to bring them up so you can see the camera, but if you go like this, in and out, that's what this motion is right now, and it'll be easier to see if we flip over to the top here. You can see it coming in and out like that. And there's actually, in order to stack up, I had to stack up the joints in order to get it to move around that motion, so there's like 3 actual individual pieces that move. And I've tested this before. This type of joint definitely works. I've used it on my exoskeleton, works really well. But that's how I was able to, that's the only way to get it, because it'll be too bulky if I didn't do it that way. So that allows for the internal and external rotation. And then the last joint is the raising and lowering of your arms, also called, what do you call that? Abduction and adduction of your arms. So flapping your arms like a bird. So if you go like this, James, you'll have that motion. And that's the motion you see on the ends here. Let's see it come in and start here, right there. So right there, it just goes down for a second at the very end of this study. Let me turn this study off and I'll show you. So now I'm just driving the joint here, and here you can see it going up and down, up and down. And so that is the ability to bring your arm up and down, up and down. So one thing you'll notice about this suit is joint it in the front and joint it in the back. The front, there's a chance it may limit motion too much. It will definitely limit your motion some. Your arm's gonna run into it a little bit when you bring your arm up. If it's too big of a problem, it can just be completely removed, and the back structure should be enough to support it. But I want this to be a power armor suit that you're completely locked into, James. So that's what I'm doing here. So it's gonna be, the joints, there's a big joint in the back, and then there's a corresponding smaller joint in the front, and it goes all the way through. So all the axes are controlled on both sides of your body. So it's like, you know, there's a part of the joint on both sides of your body, which is cool. All right, let's talk about how this thing is gonna be powered, because it is power armor after all, right? So these guys in here, can you see that? There, I made my mouse larger. So this piece right in here, this guy right here, that is gonna be an anchor point that goes in, it's gonna go in and attach with the arm, so you can't really see how it's gonna be supported yet, but it is gonna be supported on both sides, and there's gonna be a hydraulic cylinder that's gonna go into the arm. It's gonna allow this thing to pull, I haven't run the numbers yet, but it'll probably, like I would say maybe 150 pounds, like you'll be able to curl it, and then hopefully be able to deadlift it too, so I'm gonna do something similar on the legs. The problem with that is it's like, if you just power up the arms, there's gonna be so much weight hanging down on your shoulders, James, it can be very uncomfortable because the suit's metal and hard, and it would hang down, and that's not good. And because this suit is completely jointed, you know, as you can see, this thing is fully jointed all the way up and down. Let me show you the other joints on the suit really quick. So here's where the arm attaches here and here, and then here's where the neck attaches here and here, and then here's where the lumbar attaches here and here. So this suit is jointed all the way up and down the entire body. So what you want to do is you want to take the load from the hands and transfer it to the ground through the suit. So the way I'm going to do that is there's going to be some spots for some artificial muscles, which you've worked with before, James. We may have to use like Kevlar on them to make them a little bit more strong. We'll probably keep them at pneumatics. You know that I've made some hydraulic ones that are super high force. We might not use those, but we can definitely use some pneumatic ones. And there's some anchor points here and here, and here on the suit, and those are going to be your abdominal muscles essentially, and so they're kind of cross across your body, and then they can all be turned on and just essentially lock out your torso, and then the same thing is going to happen on the neck too. So there's going to be I haven't put the ones in the front yet. I need to put the ones in the front, but there's going to be some coming up to the front to lock it down that way, and then there's going to be some coming down the back that attach into the shoulder girdle and actually keep the arms up a little bit too, and those attach into these points right here and here. So you see round hole there for an exo muscle to go through, pneumatic muscle, whatever you want to call them, and one here for those to go through. So this entire thing essentially be able to just hook in some compressed air, and then the suit should kind of become rigid, and then that'll allow you to transfer that load from the heavy lifting of the hydraulics to the ground. In theory, you won't even feel the weight, in theory. And then there'll probably be one more coming from the head all the way out to the arms here. And we might not use that one, but I'm gonna go ahead and put anchor points for it in case we do. It'll be kind of awkward looking because it'll become like all the way out, almost like a Predator or something like that. But that'll really hold that load if we're having trouble with the smaller ones in the front and the back. I'm worried about the shoulder girdle sinking down, so I'm putting extra parts in to keep that from happening. Hey guys. Before we get to the rest of the video, I am sitting here doing some editing, and I realized I forgot to put part of it in. So I'm gonna go over that part really quick, and then we'll get back to the rest of the video. Okay, the part I forgot to say was how how James is actually gonna get in and out of the suit, right? So there's a bolt that comes here and here, and there's one hiding right there, and then another two right here and right here. And so if I turn off the front part, you can see how that slides over, and then these series of bolts is what holds that back cap on. But the part will slide over the top of it and then bolt in from the sides, and then the same kind of thing will happen up here. This is all the front part, right? If I take this part right here, this is all the front part in here. If I take this one and turn it off, you can see how that would slide underneath, and then two bolts come in this way. And the reason they're countersunk is so that the arm doesn't slide into that. But I wanted you guys to know, like, how do you get in and out of this thing? You get in and out of this thing with bolts. All right, there's some parts in here, like these parts and these parts that, and let's see, this part right here and this part right here, and then there's like a piece right there, there's a piece right there. These are all sheet metal parts, and these parts are gonna be, they're being designed for 22 gauge stainless steel, which I believe is like 31 thousandths thick. Those will be formed on top, and so the way they'll look when they come off the laser cutter will be like this. They'll just be struts like that. And I actually have this piece right here. So this is kind of what we're designing, right? So this guy right here is where we're going, and you can see the terrible welds. This is my first start at the thing right here, but this is kind of where we're going. So this is how it'll look once it's welded together with the how it comes off the laser cutter. This was like a test piece of mine. It's not an actual part of my suit. And then I forgot to have these too. So this piece these pieces right here are gonna be the neck pieces that allow your head to go forward and back, and also the lumbar pieces down there. So they are these pieces right here and these pieces right here to allow your head to go forward and backwards. And then this big piece in the back here, this piece right here, is this, except this is a 3-inch one, and the one I have designed here is a 4-inch one. So this is gonna be a big honking piece, be fun to machine on a Tormach lathe. But this is the part that's like your sternoclavicular joint. It goes right back here. So yeah, the sheet metal will get formed out and then welded on top, and that's just gonna make it more structurally sound and also make it look like more complete armor. And then the last thing I want to talk about are these 3D printed parts in here. So if I turn me back on there, these parts are designed to press onto your bones, because this thing is an exoskeleton, so it wants to move with your bones. So these parts in here, these were made out of a hard plastic, and this one's really uncomfortable to wear, but the ones I'm working on my suit now are 3D printed out of a flexible material, and we'll have to figure out the best way to do this. We could use an FDM printer. There might be a better way to do it too, but these will be soft and squishy, and hopefully so they don't hurt. But they need to be like somewhat rigid so that when you move, the suit moves with you. You don't want to make them out of like super squishy foam or something like that, because they want to rest on your bones, on your your breastplate in the front and then on your spine in the back. So that's how this thing will be moved passively. So when it's not powered, you still need to be able to move around the suit. These kind of things are gonna be how it's done. So I believe that's everything I have for you, James. I'm pretty excited about this. I hope you are. It makes me pretty excited. Like, it makes me smile to see this. It's really cool. It's a first of its kind exoskeleton. No one's ever done anything like this. And I've been to exoskeleton conventions. I've seen what people in industry are working on. No one's doing this. This is a unique thing that no one else is doing. To have a fully jointed suit like this, and you're gonna be completely wrapped around in it too. So it's literally going to be power armor. It's going to be very cool. Yeah. Thanks for watching, guys. Thanks for watching, James. I hope you're as excited about this as I am. You guys are great. Have a good one.